Welcome to Center of Math's Problem of the Week. For this week's problem, we want to find all integers, positive integers, n greater than or equal to 2, such that if we have n complex numbers on the unit circle that sum up to 0, then the complex numbers must be equally spaced on the unit circle. So it turns out this is only true for n equals 2 and n equals 3. To show this, so we can adjust this problem a little bit. So we can think of this process as think of each complex number as a vector, and then adding up vectors, you put them n to n and put them together. And if we have the assumption that these n complex numbers sum to 0, so these n vectors must sum to 0, so they must close together to become a polygon, a closed polygon. So I want to prove for n complex vectors, each on the circle, so that just means each vector is length 1. They sum to 0, so it becomes a closed polygon. And we want to show that for each n, can we show that they must be equally spaced. For them to be equally spaced, we want each of these angles to be the same, since the angle between each vector is just going to be 180 minus the angle between the vectors each with their beginning at the origin. So we want to show, for each n, where we're given a bunch of unit vectors, can we only form a closed polygon that's equal angular. So first, for n equals 2, clearly we just have two vectors pointing away from each other. N equals 3, we have an equilateral triangle, and by side, 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 this is the unique answer. So n equals 2 and n equals 3 do work. For any n greater than that, for example, 4, you can make a rhombus. This is, shows us an example that's where they're not equally spaced. For n equals 5 or greater, you can kind of just make two of these into one side and just make sure the rest kind of go back. You can imagine that if these were free-forming, they would not be a rigid object. And so that establishes that for n greater than or equal to 4, this does not work. So 2 and 3 are the only answers to this. Thanks for watching. Please check out centermath.org and follow us on Facebook and Twitter. Thank you.